Hello all. Today I'll start with section 3.1. Our 3.1 is about differentiation rules. But before talking about the differentiation rules, let me explain to you, if you have a function, for example f of x, how will be our notation to show the derivatives. If I have a function f of x, any function given as a f of x, you can use these notations to show the derivatives of this function. The first one that I used for you is f prime. F prime means the first derivative of the given function. You can write as a f prime of f of x, or the other notation which we call it the Leibniz notation. He shows the derivative as a d over dx. D over dx of f of x, which means d over dx or d dx, it means the first derivative of your function. Remember, if you are using d over dx or d dx of f of x, d dx or d over dx, it doesn't show a ratio. It's just an operation notation for derivatives. It's not a ratio, correct? This is the two ways that we use the derivatives, the notation. Usually I am using a lot f prime or the prime notation for derivatives, but because it's really easy, it's really fast to use. But these are the two types of notations that we show the derivatives of a function. Now, let's start with the rules of differentiation or the rules of derivatives. The first rule is the derivative of a constant number. Number one, if I have f of x equals c, a constant number, for example, f of x equals 2. 2 is a constant, c is a constant, then the derivative of a constant number is always 0. Here I can write f prime of x equals 0. Or I can write in this notation, d over dx of c always gives me what? 0. Numeric example, f of x equals 2, then f prime of x equals 0. Because 2 is a constant number, immediately the derivative of a constant number becomes what? 0. Rule number 2. Power or power rule. Number 2. Power function or power rule. If a function is given in this form for you, f of x equals x to the power of n. Any number, for example, x to the power of 2, x to the power of 3, x to the power of 4, x to the power of 100, any number, x to the power of n. What is the first derivative, or how to find the first derivative of power function? F prime of x equals, what you do, you bring this exponent here, n times your x, you subtract 1 from your exponent, n minus 1. That's the rule. Or if I write in other notation, d over dx of x to the power of n equals n times x to the power of n minus 1. This rule makes, if you have a function, it really makes your job easy to find the derivatives of every single variable or every single term which comes as a power rule, correct? I'll do a numeric example, but later I'll use a combination of few rules in one problem, correct? Let's do an example for this. For example, f of x equals x to the power of 5. Then d over dx of f of x equals d over dx of x to the power of 5. Now, based on the rule, it will be 5x to the power of 5 minus 1, which gives you 5x to the power of 4. It means your f prime x equals 5x to the power of 4. The first derivative of x to the power of 5 is 5x to the power of 4. Another example. F of x equals x to the power of, for example, 3. Then f prime x equals d over dx of x to the power of 3. Then f prime x equals 3x to the power of 3 minus 1, which gives you 3x squared. We call this rule the power rule or the power function rule. Correct? Now, if you have a constant times a function, if you have this way, f of x equals or y equals cf of x, a constant times a function, then how to take the derivative when you have a constant times a function? D over dx of c f of x equals, you can take the constant out of the derivative outside c, then d over dx of f of x. Keep the constant. It's basically the same as limits. When you have if you remember in chapter 2, if you have a constant, you take the constant before the limit and you take the limit of the function. You take the limit, the part that you have variable in it, right? It's the same thing. If I do an example for it, for this one, for example, this one, f of x equals 2x to the power of 4. 2 is my c. Then I can write f prime x equals d over dx of 2x to the power of 4. And from here, I'll bring the constant outside, then f prime x equals 2 d over dx of x to the power of 4. And we learned this one in rule number 2, how to deal with power rule. Subtract 1 from the exponent and multiply 4 in the front, right? Then f prime x equals 2 times 4x to the power of 3, which gives you 8x cubed. The next rule, let's do one more example or two more examples, then I'll jump to the next rule. For example, they are asking you to find the first derivative of negative x. Find the dx of negative x. When you write negative x, you actually know it's negative 1 times x. Then the first derivative of this one will be negative 1 d over dx of x, which gives you negative 1 times d over dx of x is 1. Because you see, if you have x, actually it's x to the power of 1. You multiply 1 here, and 1 minus 1 gives you x to the 1 times x to the power of 0. and x to the power of 0 is 1, it will be 1 times 1, which gives you 1. That's why the derivative of x is always what? 1. And your answer becomes here negative 1. Now, the addition and subtraction rule. D over dx of f of x plus g of x. If you have two functions, in this case, you can write like limits d dx of f of x plus d dx of g of x. Same way for subtraction. D dx of f of x minus g of x, it's equal d dx of f of x minus d dx of g of x. The rules are similar to the limit rules. The addition and subtractions, they are similar to the limit rules. Now, let's do an example. For example, f of x or y, whatever you name, y equals 2x squared plus x to the power of 5. Then y prime equals d dx of 2x to the power of 2 plus x to the power of 5. Then y prime equals d dx of 2x squared plus d dx of x to the power of 5. Now, here I have a constant. Y prime equals, I can put the constant here too, d dx of x squared plus, what is d dx of x to the power of 5? It will be 5x to the power of 4. Now I will simplify here. Y prime equals 2 times d dx of x squared is 2x plus 5x to the power of 4. Then y prime equals 2 times 2, 4. 4x plus 5x to the power of 4. This is how you use, or this way, the addition or subtraction rule in a function. It means if you have like multiple terms in a function, 2, 3 terms, you can take each term, the derivative of each term separately. Correct? It makes our job easier to apply the rule on each term. Now let's do some more examples. For example, y equals x cubed plus 5x squared minus 2. They are asking us to find y prime, or the first derivative of this function. Based on the rule, I can write this one, y prime equals d dx of x cubed plus 5x squared minus 2. Then y prime equals d dx of x cubed plus 5d dx of x squared minus d over dx or d dx of 2. y prime equals d dx of x cubed is 3x squared. 3 times 1 minus exponent. Plus 5 times d dx of x squared is 2x. Minus the derivative of a constant number is 0. Then y prime equals 3x squared plus 5 times 2 gives me 10x minus 0. It means y prime equals 3x squared plus 10x. Correct? When we are talking about the power rules, we have another power function which is e, right? E to the x. Let's put one more formula. If you have f of x equals e to the power of x, function e to power of x, then f prime x equals d dx of e to the x. d dx of e to the x always gives you back e to the x. I'm trying at this time to avoid proofing all of these. All of them, they have a proof. Why the first derivative of e to the x is always e to the x. There is no time for proof at this moment, especially when I'm talking to you online. Only that I have to remember is this rule. The derivative of e to the x is always e to the x. Correct? Let's do another example. A function f of x equals e to the power of x minus x is given to you. They are asking you to find the first derivative of this function, then in part B find f double prime. It means the second derivative of this function. Now, I will start with f prime. F prime x equals d over dx of e to the power of x minus x. Then f prime x equals d over dx of e to the x minus d over dx of x. F prime x equals d over dx of e to the x is always e to the x minus the derivative of x is always what? 1. This is the first part of the problem that they ask you to find the first derivative of the function. F prime x is e to the x minus 1. Now, second part, I'm looking to find the second derivative of a function. Every time that they are asking you to find the second derivative of a function, first you have to find the first one, then use this function and take again the derivative of this function. It gives you the second derivative of the function. Correct? Now I'm using this to find the second derivative of this function, or f double prime. F double prime of x equals d over dx of this function, e to the x minus 1. Now f double prime x equals d over dx of e to the x minus d over dx of 1. Then f double prime of x equals d over dx of e to the x again gives you e to the x minus d dx of a constant number is 0. Then f double prime x equals e to the power of x. This was all in 3.1. 3.1 is talking about 4 easy rules. The derivative of a constant is always 0. The derivative of a power function, it's n times x to the power of n minus 1. The third one, if you have the addition between two functions, you can take the derivative of the first function and you can take the derivative of the second function. And same way for subtraction, and the last one, the derivative of e to the x. 4 rules or 5 rules that I explained in 3.1 for you, and 3.1 of your book is only and only about these 4 rules, correct? Let's take one more example to make it more clear for you. For example, a function g of x equals e to the power of x plus 2x squared minus 3 is given to you. They are asking you in part A to find the first derivative of this function. It means first find g prime of x. G prime of x equals d over dx of e to the x plus 2x squared minus 3. Now here I have addition and subtraction. I'll take the derivative of every single term, right? Then g prime x equals d over dx of e to the x plus d over dx of 2x squared minus d dx of 3. G prime x equals d dx of e to the x is e to the x plus d dx of 2x squared. You can write this one as a 2 d dx of x squared. But after practicing few problems, even you are not required to show it this way. Immediately, what is 2 times 2? 4, and 2 minus 1 is 1. It means the derivative of this part or this term will be 4x. Soon you will see here the derivative is 4x. But at the beginning to practice, you can write this way. Minus the derivative of a constant term is 0. Then g prime x equals e to the x plus 2 times d dx of x squared is 2x. G prime x equals e to the power of x plus 4x. This is the first derivative of the second function. For example, in part B of this problem, they are asking you to find the second derivative of this function. Now, what I do, I will use this function, which is the first derivative of the given function, and I'll take the derivative again from this function. And I'll end up with the second derivative of the given function. I will write this answer here in the top. G prime x equals e to the x plus 4x. And now I am looking for g double prime x. Then g double prime x equals again d dx of e to the power of x plus 4x. Then g double prime x equals d dx of e to the x plus d dx of 4x. G double prime of x equals the derivative of e to the x is e to the x plus the derivative of 4x gives you 4. And this is the second derivative of the given function. This was all about 3.1. Your 3.1 is really short, just 4 rules or 5 rules of the derivatives. We will continue in next lecture the other rules of the derivatives. Then I'll give you the product rule, the quotient rule, and after we practice with product and quotient rule, then in the next section we will cover the chain rule for you. But 3.1 is all about simple rules of the derivatives. You are not required anymore to use the different quotient formula or the base formula for derivatives. After this, you are just applying the rules that now you're learning, like limits, and you find the derivative of any function. Again, on Wednesday at 9:15, I'll be online, and I will kind of repeat this lecture on Zoom for you. If you have time, please come online and we will discuss, and if you have any question, you can ask me tomorrow at 9:15 on Zoom meeting. Have a great night and be safe.